Hi everyone, I welcome you all to our amazing ML marathon. This is going to be an amazing experience for you all. Today, I am Chavigar, your host of the event, and I welcome you to the Azure Developer Community's amazing initiative of ML Marathon. Now, you might be thinking how this is going to help you and what it is all about. ML Marathon is all about telling you all, teaching you all. About machine learning, and it's going to be very amazing experience because we will be explaining everything from scratch, so you will be getting an amazing experience from the beginning, that how machine learning actually looks like, what is actually machine learning. So there are various misconceptions that goes into, and also with that note, we will be covering the basic algorithms of machine learning. We would be talking a proper talking about Python as well, and we will be having an amazing hands-on experience of machine learning. So with that note, I want to welcome you all with this with like the today's marathon of machine learning. Also, how we are going to proceed with this is our day one, in which we would be receiving all the knowledge of machine learning, hands-on experience and everything. And tomorrow, after this particular workshop, you would be receiving a data set on your mails, and also you would be receiving a problem statement. What you have to do, you have to go to the website where you have registered for the ML marathon again, and there you have to you will get an option of the dashboard. You have to click on the dashboard, and after that you will be receiving some questions. You have to fill the question, fill the answers of those questions. You have to submit your solution of that problem statement, and then let's see who all will be receiving the Microsoft merchandise and zippers from Microsoft Azure, because the top 10 projects would be receiving it, and also you will be getting like more than 24 hours to submit it. So let's see who all will be going to receive it, and it's gonna be very much amazing experience. So with that note, I would be very happy to welcome Pallavi ma'am to this amazing session, because she is the expert today, and she is so amazing with EI, ML, and data science. Right now, she's working at KPMG. So, with that, I welcome you, ma'am, in the today's session.
So yes, thank you, Savi, for introduction and telling brief about. So hi all, I am Pallavi, and I'm going to be your mentor for the next 2 days with the ML marathon. So on the day one, we will be discussing the machine learning techniques from scratch. From advanced to beginner to advanced level. So let's get started with me into the module one. So I'm going to share my screen. Yeah. So I hope my screen is visible.
Yeah, yeah.
Hello.
Yeah, yeah, your
Yeah,
screen is
my
visible.
screen is visible, Chavi.
Yeah.
Yeah, okay. So the first module that we are going to discuss today is the introduction to machine learning. So, in this module, you are going to learn about what actually machine learning means and the basics that you need to learn before moving forward. So, let's get started. So, the first question that I'm going to ask from you is what is machine learning and why there is hype, so much hype, about machine learning, AI, and data science. So, basically, machine learning is a field of study that gives computers the capability to learn without being explicitly programmed. So, it is teaching the computer. So, we are teaching the machines to learn by themselves so that we don't have to explicitly program the machines for each and every task. So, I can explain you in the computer terms. I mean, the machine terms like a computer program is set to learn from experience E with respect to task T and performance measure P if its performance is going to improve with experience C. So, for example, let me give you an example. For example, you are learning to make a tea. So, for making the tea, you don't have any prior experience, but while I mean, suppose your mom is teaching you how to make a tea, and from this experience you are going to learn and improve. So you are learning how to make a tea. So similar to that, I mean, we are teaching machines how to do particular tasks. So that's what machine learning is going to do for us. So I mean, it's very interesting. So, what we are trying to do is we are automating and improving the learning process of machines based on their experiences without any human assistance. So, we are not going to um, do any human assistance for each and every task, but we are making the machines capable so that they can learn on their own. And what this, I mean, or in layman terms, I can say that machine learning is making machines capable, or we can say science of the teaching machines how to learn by themselves so that we don't have to teach them. I mean, for each and every task, guide them. So that's what machine learning is about. So now, what are the applications of ML? Now you know, okay, I know what is machine learning. What are the different applications of machine learning? So in the now I'm going to discuss with you some of the real life examples that you come across daily in your real life. For example, your phone screen. So you unlock your phone screen. So there's ML behind it. There's a deep learning model that I mean face recognition. Next is you shop on sites like Amazon.com or Mintra. So when a customer buys some products, so Amazon or I mean Mintra, these sites are going to recommend based on the items that you purchase. So for example, it's recommending some app or I mean some this book, anything. So this is also I mean a part of machine learning, which is recommendation systems. So let me I mean tell you. So e-commerce sites recommending you products based on your browsing history, so that's the application of machine learning. Next is voice assistants, like you tell on your phone, mobile phone. So, okay, Siri, please keep an alarm for 10 a.m. tomorrow. Or, okay, Google, please keep a alarm. So these are the voice assistants. So they are also trained using machine learning. Next is face unlock in your smartphone. So you're going to, I mean, everybody's using smartphone these days. So the first thing, I mean, you do is unlocking your face. Next is email filtering, that is spam or not spam. So you have your spam, you have your email, and some of the mails are spam, and some of them are not spam. So there is also an algorithm that is running behind this. So these are kind of the real world applications that you came across in your daily lives that are based out of ML. So I think I mean it's very interesting applications. So you can also build some of them, so using the algorithms that I'm going to teach you today. Next is okay, we understood like machine, we have to teach machines, right? You understood we have to teach machines, we have to give the capability to the machines to how to learn. Now, you might be thinking of okay, we want to teach machines, but what do machines need to learn? So any guesses from you all? So what do you think machines need to learn? So machine need data to learn. So we will be providing the machines the data on which they are going to learn. So next is data can be labeled or unlabeled. So I'm going to tell you like what do you mean by labeled data or what do you mean by unlabeled data. So let's get let's move forward. So we have different type of learnings, that is supervised learning, unsupervised learning, and reinforcement learning. So first of all, I'll be discussing with you is the supervised learning. So in supervised learning, we'll be using the label data set to teach the machine. So label data set, what do you mean by labels? So let me present you an example, and next we can, understand this. So now you see on the screen, this is the name, this is the age, this is the marks, and this is the target. So target is the, that we are going to predict, or the target column. So for example, Ram of age 23 scored 95 marks, Sham of age 24 scored 78 marks, belong to class B, and 95 belong to class A, and Geeta Vijay with age 22 marks 92 belong to class A. Now these class A, class B, class A, different type of labels are there. Suppose we have two classes, class A and class B. So these are your labels. So suppose you have a data set, and in the data set, in the training data set that you will be using, so this is going to your class A and class B is are your labels that you have with you. So you are providing the machine this whole data set along with the labels. Now this is what label data set means. Next is, okay, we got, this was the training data. So in the training data is like, you have some rows and you know the exact label. But in the real world scenario, you have to predict for some rows. For example, Sita for or Bobby for, you have to predict. So what's the target having marks this? So you're teaching, you'll be going to build a model that will give you these predictions. So in supervised learning is you have your labels. So these are your labels in your training data set. I hope it's clear now. Next is, this is a diagrammatic flow chart to help you make understand, because I think graphs are a very good way to visualize. So this is kind of visualization is, this is the data that is labeled. Labeled why? Why? Because it is having the target. Next is we are going to give this entire data set to the algorithm. And now algorithm, we are going to train on this data set, and what we are going to get? Output is a model. So model will be your output, and on unseen data set is your like this. So this will be your unseen data set, and you have your model, and you will be using the model to give the predictions for these three rows. So that's how the flow works of supervised learning. So I hope, it's clear. uh, Let me, confirm with you, it's working fine or not. Okay, so this was the flow that we did. Next comes the unsupervised learning. So in unsupervised learning, we have, now you understood what do you mean by label data, and unsupervised you understood. I mean, there the data is going to be unlabeled. So unlabeled means we don't have the labels actually. So in unsupervised learning, we are going to use the unlabeled data set to teach the machine. So the goal of unsupervised learning is to find the underlying structure, and we are going to find the patterns in the data set. So for example, let me share you an example, and then you can get it very clear. So we will be utilizing clustering techniques to group the data set into groups. So what do you mean by, we'll be using clustering techniques, and what do you mean by an unlabeled data set? So let me present you with an unlabeled data set. For example, you come across this data set, okay? So now we as a human knows, okay, this is a circle. We know this is a triangle, but how do machine will know, okay, this is a circle and this is a triangle? So what it's going to do is it is trying to find some, i mean techniques. Okay, so these are looking similar, these green points, these circle are looking similar, so let's, this is going to be one group. Next is this triangle is looking similar, okay, this can be one group. So I am providing you in layman terms. So what this is going to mean you. So this is an unlabeled data. Unlabeled data, you don't have the labels. Means you don't know it's a circle or it's a triangle. So how do I mean machines will do. So now we are going to do is clustering. So let's cluster them. So cluster is basically grouping the similar things together. Let me present you an example. Like this is cluster one and this is cluster two. So let me provide you an real world example. So I think, I mean, for example, you are a group of students. So some of the students might be liking maths, some of the student might be inclined towards science, and some of the students might be liking, I mean, they are artist kind of person, so they'll be like painting, anything like that. So, I mean, what we are going to do, we are going to, I mean, everyone is in a single group, but we want to identify the similar people. So, okay, so these persons are liking maths more, so let's cluster them into one group. These persons are liking science more, so let's move to this group too, and so on. So we are going to cluster them into different groups. How? That we're going to see in the module 6, I think. With the clustering technique, I'm going to show you how we'll be using the k-means or hierarchical clustering to do this kind of clustering, how to, I mean, map these to the clusters. So now I hope, I mean, now you know the difference. So some of the in the interview questions also, they ask you, oh, so can you explain the difference between the labeled and the unlabeled data? So now you know. So labeled data, in the training data set itself we know the labels, but in unlabeled data you don't know. So unlabeled data we have a supervised learning, and unlabeled data we are going to use unsupervised learning. That is the clustering techniques. So this was about the unsupervised versus supervised and labeled versus unlabeled dataset. So next, I mean, let's move forward with that note. Next is the reinforcement learning. So now you know, okay, in supervised learning you have the labels, in unsupervised learning you don't have the labels. So reinforcement learning is kind of a middle one. So in this, what we are going to do, we have an agent that takes an action in an environment, and based on the action, it receives your positive reward or a penalty. Penalty, we can say negative reward. So Mm, let me frame your question and then you can say, like, what do we want at the end out of the reinforcement learning? So, we want a sequence of actions that will lead us to gain the maximum reward. So, let me explain you this with the help of an example. So suppose you have to teach your pet, you have a pet, you have a dog, and you have to teach your dog to reach a goal. So suppose there is a gate, I mean forward, and you're teaching your dog to, I mean, to reach to that gate. So your dog is not aware, I mean, so he will be he can move left or right or in any direction, but you are teaching your pet, you how you will be teach. So if he takes action, and if he's moving in the, I mean, straight forward to the gate, if he moves in that direction, he takes steps, so you'll be giving some reward, say you'll be giving some bones. But if it's moving away from the gate, or he's moving towards left or right, so that means he's not moving towards the goal, so you'll be taking some bone from it. So in this process your dog is trying to, I mean, will learn how to do this. So um, so your pet will learn which action to take. So okay, so he will learn, okay, if I'm moving forward I'm getting a bone, but if I'm moving left or right I'm not getting a bone, and I am getting negative reward. So what your pet is going to learn in this situation, and he will move towards the goal, and he will learn in this process. So your pet is learning from its own actions. So he's moving left, is not getting bones, moving right, not getting bones, moving straight, getting bones. So it's learning at from its own action, as it's a trial and error approach. So this was about, I mean, the takeaway from the reinforcement learning. So in reinforcement learning, if I have to summarize, so in reinforcement learning we have an agent. An agent will be taking the action in an environment, and based on the action he will take, so if he's taking right action, you'll give them the reward. If you take if he takes negative, I mean other actions, so you are going to give him the negative reward. So based on this process, he's learning from its own actions. So that's what about reinforcement learning meant. So you can, I mean, I have presented you in the slide, so you can also go through this example once. I mean, if you want, I can read you from the slide also. But I'm going to stay for, I mean, 30, 20, 30, 40 seconds for here so that you can, I mean, read it out. Next is the same thing I have presented with an example because this diagram will be easy to remember for you. So this is an agent. Okay, so this is an agent and that is performing in your that is performing some actions. Actions can be your moving left, moving right, or moving straight. Environment in which it's taking place, and the reward and the next state. So that's what about reinforcement learning. So let me provide you a recap of what we learned till now. Supervised learning. In supervised learning, we have learned we will be given with a labeled data set. For training, in unsupervised learning, we don't know the labels. So how it is going to do, machine is going to do, it is going to cluster. Okay, it is going to group similar things together. It is going to use clustering techniques. And in reinforcement learning, we have an agent and that is performing some actions. And based on the right actions, we give them positive reward. And based on the wrong actions, we'll give them negative reward. So this was all about, I mean, different kind of learnings, supervised, unsupervised, and reinforcement that we have in machine learning to give you a basic idea of, I mean, what algorithm falls in which area. So I hope it's clear now. So I mean, we'll be taking some break for 10 minutes and then we'll be moving towards the module 2. So in the meantime, what I want to tell you is like, this is the, I mean, I hope, I mean, Savi shared with you this link, github.com. So, in the meantime, what I want from you is, so these are the installation guidelines for the, I mean, hands-on project that we are going to do today. Or I'll be teaching you linear regression, logistic regression, everything with a hands-on experience. So if you can also try on the live, and but before that you'll be needing some, I mean, um, things. So you'll be needing Jupyter Notebook. So if you have already, then you don't need to install. Otherwise, you just need to install using this. And we need Python and a few more packages that you need to install in the Anaconda terminal. So these are the installation guidelines. So in the 10 minutes break, you can actually, I mean, go to this repo, that is Data Science Works. So it's double S, and you can follow this process to, I mean, install. So we'll be taking 10 minutes break and I'll be there at 10:40. Yeah.
Yeah. Also, some of you were asking that, will this session would be recorded? Yes, the session would be there on our YouTube channel only. You can just check it out after as well. But it would be really great if you can just have a quick learning right now, because you would be receiving an amazing problem statement and data set as well on your mails. So it would be great if you could just get started with your machine learning journey right away and receive all the knowledge and work on the problem statement by like EOD. So it would be really great. And also, if you have any sort of questions, you can just put in the comments below. The link, you can just see that in this banner it's coming. You can just register for the ML marathon. It's reskill.com/hack/ML marathon. You can just register if you haven't registered yet. Okay, sure. The repository link would be shared with you in few minutes over the comment section as well, over the mail as well, and everywhere. So don't worry about it. You can just check it out. Okay, till then we are just having this 10 minutes of break. You can just work on your skills. You can just do some sort of more research of machine learning at the same time till then. And I'm just putting the repository link right away. So yeah, here it is. You can just check this out. Here we go. And perfect, you can just check this out. This is our repository link. You can just have a look into it, check this out, and then it would be really great. Like in this 10 minutes break, you can just explore more about these stuff, and there's the whole walkthrough is given. You can just have a look into it. Till then, I have shared in the comments below. regarding the questions that uh, regarding the questions that will we be receiving the certificate, yes. Like if you would be completing this whole ML marathon, you would be receiving a certificate that yes, you have successfully submitted, that you have participated in it, and it will be from Microsoft Azure, obviously. So it's going to be really a great experience for you all. uh, the soft in terms of software, we would be just giving you a walkthrough of the software as well, so don't be worried about it. Okay, we'll give you a walkthrough of everything. It's just you can just go through the repository once. You can have a look into it. If there is any doubt that is coming to you, you can just keep your doubts with yourself for now, and then you can ask them after 5 to 6 minutes when we will restart it. So till then, you just keep your doubts, be prepared with amazing doubts and everything. Have some more research on like how actually these stuff works, how it looks like. So now we'll be right back in few minutes.
So, hi everyone, welcome back, and I hope you installed in this 10 minutes break all the necessary packages. So, before moving to module 2, let me provide you, the discussion about day 2. That is, on the day 2, you'll be given a challenge means a data set. On this data set you'll be given a problem statement, and like you'll be given the attribute information, everything you'll be provided. And I have tried to answer every question in that the PDF document itself. Like, what's the input from our end? Input is the files, and the process is you have to try your solutions and the what I want from your notebooks. And the selection criteria is, I also have defined 4 to 5 points that we are going to judge on the basis of those 5 points. Like, we will be interested in knowing the I mean not just how you understood the data set, right? Next is how you visualize the data set. Okay, so what features you considered important and how you do visualization. I'm not interested in the number of graphs that you plotted, but I'm interested in the information you got from each and every graph, and did you use that information moving forward. Next is, you, for example, you tried some basic model, and then you move to some other model, and why did you make a transition to that particular model, and why you settled for the final model based on the, some metrics. So you're going to, like, accuracy or precision or recall. So why, you moved. So you have to provide me the reasons in the notebook. And finally, you have to give the predictions for the test data set that we have given, and you have to provide it. So Chavi will be, sharing with you the whole, the kind of document plus the Excel sheets, and I tried to answer each and every question that you might be having in that document itself. So please refer to that document for any question, and you can always ask me and Chavi for better clarifications. So with note of this, so I'm moving forward to the module 2. So now you understood, I mean, the different type of algorithms, but what we are interested in now is, I mean, unsupervised learning, reinforcement learning. So these three learnings we got it along with the examples. So yeah, let me present my screen. I think I'm presenting. Yeah. So the module two, like the basic ideas, you have to give. So like, give me a minute. I'm checking something. So the module two is basically kind of what is a regression, the basics that you need to understand. So I'll be discussing different type of algorithms with you all, like regression, classification. So before that, let's understand what do I mean by regression, or what do I mean by classification. So basically, regression is a technique that relates a dependent variable to one or more independent variable. Now so let me frame you a question like, I have written some function. So say y is equal to 2x plus 2. So x is your, so you put some value, say 1. So x is equal to 1. So what you'll get, y is equal to 4. Now you put 2. So 2, now what we get, 6. So you are getting the y based on the x. So what this x is anything, I mean independent, that takes on any value, but y is depending on this variable. So y is dependent and x is independent, and the relationship between the two, what is the relationship? Relationship means how they are related. They are related by this equation, y is equal to 2x plus 2. So x is your feature, that is your independent variable. Y, what is y that you're going to try to predict. So this is your dependent variable. So in the regression, please keep a note of it, or this question you might also be asked in the interviews. So the main difference between regression and classification is the target variable is here will be a continuous value. So in regression, you'll be having some continuous value output. For example, if you want to predict the price of house, so price of house can be 50 lakhs, 1 crore, so, or 50 lakhs, 50.5 lakhs, right? So it is a real value. Or the salary of a person is also, I mean, continuous value, or the age. So the target variable in regression is going to be a continuous value. And what is regression? That is going to model the relationship between the dependent and the independent variable. So dependent is that you're going to trying to predict, and the independent that can take on any values. So let me, I mean, explain you with a real life example what where we can use this regression concept. So for example, you're going to buy a house, so house price. So you're going to buy a house, so you know, you want to know, so where the house is. So the is the area of house, what's the area of the house, it's big or it's small, what's the location of the house. Okay, so it's in a very good area or it's not in the very good area. So these are some of the features that are corresponding to the price of house. Okay, so house price is your, what is house price? Can you, I mean, tell me in the YouTube comment chat? So what is the house price? I told you. So house price is the dependent variable, right? Most of you guess it right. And area location. So house area and the area location are your, what are they are your features. So that corresponds to the, that are adding to your house price. So b1 and b2 are your coefficients. Some coefficients, it can be anything, I mean 0.1, 0.2, anything they can be. So this is the relation. So you can use regression. So if someone asks from you, okay, so can you tell me the real life example of regression, you can say, okay, if you want to buy a house, if you want to predict the price of house, that is a, I mean, that you can do with the help of an linear regression. So linear regression I'm also going to do, but now you got the idea what regression is trying to do. It's trying to model the relationship between the dependent and the independent variables. So I hope the main idea of regression is clear. So now is what's the classification? So two things we are going to learn today is, I mean, the regression and the classification. This is the introductory module that teaches you, I mean, the basics of what actually classification, because this event was open to all the participants who are not from ML side or computer science. This event welcomes all. So I'm going to do a very basic things also. So let me provide you now what is classification. So classification, you all know. So it's the process of categorization of data set into classes. For example, you have this data set. I have shown you this data set previously also. So if I, for example, if I give you this data set and provide you, okay, classify this data set. So what people can do, okay, so ma'am, this green are my circles, and this triangles are my, these blue ones are my triangles. So I classified the data set. So that means you have categorized your data set into different classes. So suppose there is square also, or there is some pentagon, hexagon shape also, that also you can categorize, and you will be having some different classes. So that's what classification. So now can you note the difference between the classification and the regression? In regression, what we were trying to do, we are trying to predict the continuous value, and here we are categorization the data set into we are doing the categorization of what, of your data set into different classes. So we are grouping the things together, okay, in classification. So can you tell me, I mean, what you can do to group things together? Which techniques you can use? If you can tell me which techniques you can use to group things of data set together. I've told you in the I mean, module 1, yes, you can do clustering. You can apply different clustering techniques to do this categorization also of an unlabeled data set. Next is so I mean, the main difference, if someone asks you in interviews or in ML interviews, so what's the basic difference between the regression and the classification? You can say here the output is a continuous value, and here the output variable of a classification is a category, such as yes or no, or spam or not spam, right? So for example, you're in email filtering also. So someone is sending you a mail, okay, you won a lottery of this much amount, and someone is sending you a genuine mail. So we have some algorithms like naive Bayes you can utilize for sentiment classification, or I mean, spam or not spam. So this is what it's kind of, this is a classification category. So these kind of applications belong to classification category. Okay, and stock price. One of the real example, if I give you the stock price, if you have to predict, okay, this I have the past history data, and what is going to be my stock price for the next, I mean, this month or next day, I can say. So stock price is basically, I mean, this is going to be a time series data, but it is, I mean, the value is not a classification. I mean, it's not a category, right? So this was all about the regression versus classification, and please make a note of it, of this slide, and I'll be sharing you all the slides on my this that GitHub link all provided. So I'll be making one repository for you all, so that if you want, I mean, to go back to these slides, or use these slides, so you can always, you're always welcome. So next is what is a model and how does it work. So the basic flow, now you got it. Okay, so different type of learnings you did, and now what is a model? Because basically you have your data, you train your I mean, model on this data set, and now what you will get. I mean, after training, what you will get. So you have your input is your data set, and now you're using some algorithm. Yeah, algorithm can be simply linear regression or logistic regression. What will be the output if you provide, if you train your, yes, the output will be a model. So what actually model is, I mean, and how does it work? So machine learning models can be thought of as a file. So you can thought of as a simple file. So file format can be a pickle file, okay, .pkl. So today also, you can, I mean, try going home and, I mean, try this, like building a model and saving it as. So please make a note of it. So different type of models like .pickle file you can save. So depending on the, I mean, this framework you're using, for example, you're using might be sklearn, or I mean package, or this PyTorch, right? So or Keras library you can use. So sklearn library, PyTorch library. So these are different type of models are there. So machine learning models can be thought of as a file that has been trained. What it has been trained on? It has been, definitely it has been trained on a data set with the help of an algorithm. So three things you have to, okay, what are those two things? You have data, you have your algorithm. So you feed your data to the algorithm to generate a model. Okay, three things: data, algorithm, model. So this is the flow. So data is your input, you feed it to algorithm, algorithm will give you the output as your model. So model is a file that you can use it for predictions. So can you tell me, after training we are going to get model. So what model is used for? Why we are going to, I mean, train a model? Why? Because we want to teach the machines, right? Machine learning means we're teaching the machines. So after you get your model, what you will get? I mean, why we are saving the model? Yes, to uh, we are using the model to make the predictions on an unseen data set, on the live data sets we predict. Okay, so you trained your model on the historical data, but next is you have your some unseen data and you don't know the labels, you don't know the price of house, but you have some features. Okay, the my area is this and my house location is this, so can you predict? So using this model you can get those predictions. So that's why we are doing the modeling, we are doing the training, and we are saving the model for future use. So I hope it's clear what is a model and how does it work. So I have written also. So what's the use of this model? So if someone asks you, okay, you are training your model, but what's the use? So we'll be using this model to make predictions on an unseen data set, right? So let me again present you an visual thing for you, so you can note the difference. And now you have to tell me the difference between training and evaluation. So I have a data set. So next step is what? I will feed it to the algorithm. Algorithm can be supervised, unsupervised, or reinforcement learning you can use. And what will be the output after training? What will I get? Please mention in the comments. Yes, model I will get. So your input is a data set, algorithm, and model. This is a training flow. And can you guess the flow of evaluating? Yes. So you'll be given unseen data to a model to generate the predictions. So this is the important slide for today. So if someone asks you what's the difference between training and evaluation, or you can just explain, I have a data set, I'll feed it to algorithm to generate a model. And if you have some unseen data set, or unseen data means what? Unseen data means you want to predict something for that. For example, you have some, say someone is saying, okay, you trained a model, you trained a linear regression model to predict the price of a house, but someone tell you, okay, my area of location is this, and my area is 500 square feet or something like that, and my location is this, so can you tell me, I mean, the price of house? So your model will be predicting the price of house. So unseen data will be what? Area and the location of house, and prediction will be the price of house. So unseen data, you might be aware. Or here data set is your, that you will be using for the training of the model. So that's training versus evaluation. And that also clears why you are using the model. So I hope, I mean, it's clear to you. So that's what I have written here on the previous example that I explained you. So Ram, Sham, and Geeta of age this and having marks belong to class A, B, A. And this was your label data. You provide it to the supervised learning algorithm. Why supervised learning algorithm I'm using, and why I'm not using unsupervised learning algorithm or something like that? Because I have the labels. So if I have the labels, I have to use supervised learning algorithm to generate the model. Model is basically a pickle file, some file, okay, that you have trained. Now you will be seeing some unseen data set. So people come, one of the person come, okay, I am Sita, my age is 21 and I've scored 91 marks. So can you tell me which class I belong to? So I can feed this data to the model. So model will say, okay, your age is 21 and your marks is 91. So you will belong to class A. Now some other person is coming. Okay, my name is Bobby, my age is 26, I scored 73 marks. So what class I belong to? So you'll be given this data to the model, and model will say, okay, you belong to class B. Third person come, Dua. I am Dua. My age is 23. My marks is 96. Can you tell me what's my what which class I belong to? Yes, he can say. The model can say, okay, you belong to class A. So this is your training. This is your evaluating. What's the use of model? Taking the unseen data and giving you the predictions. So you can also visualize this with the help of this example. So I hope, I mean, it's clear. You can also look at this slide and, I mean, to have a better understanding. Next is the next topic for today is how to define the loss function for any problem. So why am I mean, I have included this topic. So what do you mean by loss? Loss. If anybody knows, what do you mean by loss function? Loss is what? Loss is, I mean, we lost something. I mean, we have some error, right? So loss function tells you how good your ML model is in terms of predicting the expected outcome. Okay. So for example, you build your model. Okay. You build your model, but okay, so two persons are there. Person A build one model, person B also build one model. Now I'm in a dilemma of choosing the best person. So person A or person B. So how I will evaluate these things? By some kind of metrics, right? Like some, I am saying, okay, person A is, I mean, has the error of only 0.2, and person A has an error of much more larger. So I will go with the person A model because its model is more accurate. So to decide between different models that we built, which is going to be best. So how well your model is, how good your model is. For example, you're going to be have a hackathon tomorrow, and different persons will be submitting me the model, right? And the different things to me. So how I'm going to select the best person? I mean, the winner of the hackathon. I'll be using what? I'll be using, okay, this person metrics is this. Okay, this person is, so how well your model is, how accurate your model is. From that only I can specify this person model is good and this person model is not that good, and it has to improve. So what loss function tells you how good your ML model is in terms of predicting the expected outcome. Why we need it? To, I mean, know how well we are performing, right? It's kind of a test, you can say. So most common loss functions are your, if I can say, that is mean squared error, RMSE, MAE. So you might be getting confused now is what is MSE, RMSE, and MAE. I am going to discuss today with you all these errors in the performance metrics session along with the hands-on. So how you can utilize this. So let me provide you one example and then you can understand better. So we have to focus on two things. What are those two things? First one is the actual, next one is the predicted. So what is actual? Actual is that you already know. In supervised learning algorithm, we already know what's actual. And predicted is your model predictions. So we have to make the difference. So actual, for example, you know your actual value is 0.5 and your model is trying to predict, okay, 0.3. So what's the error your model is making? You can just take a difference of this, right? So okay, my actual was 0.5 but my model is predicting 0.3. So what's the difference? 0.2. So now what we need to do, we need to minimize this error. So if this error is 0.2 for one person, and if this error is 0 for another person, so my actual was 0.5 and model also predicted 0.5. So whose model is better? Whose error is lesser? So we need to minimize this error. So this error is what I mean loss functions are you're measuring. Actual minus predicted is the loss function, and different kind of summations that we can use in the mean square, RMSE, kind of things. So I hope it's clear. So you have to be clear on these two things: actual, that you already know, and predicted, that is predicted by the model. Take the difference. If you take the difference, that is the error. And what you are going to do is you are trying to minimize this error so that your model is performing good. Next is, how do we assess the performance of a model? For example, tomorrow you're going to submit, uh, different people will be trying and different person will be submitting, different metrics. So how do we assess the performance of the model? What do we need? We need different kind of metrics. So we will evaluate different metrics to know how your model is performing and then compare the results. And we will choose a metric that optimizes our goal. For example, accuracy. So one model is 90% accurate, other model is also 50% accurate. So what model is good? 90% accurate, right? If accuracy is the right metric in that area. So you also have to know that accuracy might not be always the good metric for all the data sets. Why? For example, in the unbalanced data set, does accuracy is a good metric? So this is also one of the questions that people ask you in interviews, like, does accuracy always the good metric to choose? So you can say no, accuracy is not the good metric. If my data set is, the kind of un- unbalanced data set, so I'll not be moving towards accuracy. Okay. So next we have precision, recall, and F1 score. So I'll be teaching you all these accuracy, precision, recall, and F1 score in performance metrics module. And tomorrow also you have to predict precision, recall, and F1 score of the challenge that we're going to share with you all. So these are, the end of module 2. So I hope it's clear now. So we came to the end of module 2. So what we understood, we have gone through different type of algorithms. That is, we get to know supervised, unsupervised reinforcement. We get to know, uh, this regression. We get to know this. We got to know this classification. हमने classification we did, and we also understood the difference between the training and the evaluation. We also understood how to compare different models using the metrics and the loss functions also. That's complete our module 1 and module 2. So any questions if you have, you can uh, tell me in the comments. I'll try to clear them module wise, because in the end you will be having some doubt session. But still, if you have some question on these two modules, please feel free to ask me in the comment section. So we'll be taking a break for 5 minutes, and then we'll be moving to module 3. So, hi, all. uh, I hope if you have any questions, you have got it answered from Chavi and me. So, next, the module that is scheduled for today is the module 3. And in this module 3, I have, already explained you what is regression. But now let me discuss some of the very important ML algorithms. That is, first one is the linear regression. So, before moving to that, so can you all please go to this repo? In this repo, you have to go to machine learning. So in machine learning, I have uploaded all the notebooks, right? So I have already told you that you need to install Jupyter Notebook using the installation guidelines. So let me go back and provide you the installation guidelines. So one person asked like they have installed Mini Conda. So is it okay? Because if we don't have, yes, so Miniconda is a minimum version, a smaller version of Anaconda. So you can use that. So I hope this it's clear. So you'll need Jupyter Notebook and the Python and the few packages to learn to go through these notebooks. So what you can do is you can basically I'll be teaching you the hands-on, but you can also try it now. So the link is provided to you. So linearregression.ipynb. So you can basically download it, and using download, you can run this in your notebook, your local system. Okay. So So I am providing you the hands-on for, everything for algorithms also. So for the linear regression, so first we will be discussing the what linear regression actually means and what's the process, what the working, and finally we have a coded. So in the coded session, I will be going towards that notebook. So in the meantime, you can, so I'll be giving you 2-3 minutes also for downloading that notebook. But if you can do it now, so it will be better for us. So let me present you the slideshow from beginning. So linear regression. So, agenda for today is we are going to discuss what is linear regression. We are going to understand the equation of linear regression and the graphical understanding of linear regression. And finally, we will be implementing the linear regression on a data set in Python. I have already shared you the notebook with the GitHub link repo in the YouTube chat. You can also, go to that. And so we please share the GitHub repo link again so that people who joined now can also, see that. So you can go to that, to the machine learning repository and download the linear regression notebooks. And finally, when we are going to code it, so it will be handy for you. So with that note, let me get started into this. What is linear regression? So what is regression? So can you tell me what is linear regression? So linear, what does linear means? Linear means a line, a linear relationship. So yes, so linear regression, if someone asks you what do I mean by linear regression, simply means we are using a line to model the relationship between the dependent variable and the independent variable that are your features. So dependent variable is what I've told you in the initial slide, that is your house price, the price of house. In that example was your dependent variable. And what are your independent variable? What are your features? Features are your area, location, and the area of the house. So linear regression means we are using a line. So if I have to model the relationship between the dependent and the independent variable, if I have a data set, what I am doing is I am just doing drawing a line to model the relationship to, I mean so that's what linear regression means. So we are using a line to model the relationship. And what does line comes from the name itself, linear, right? Next is what's the equation of the line? Let me go deeper into the mathematical side of this. So y is equal to mx plus c is the equation of line. Y is your, dependent variable that we are going to predict. X is your independent variable, that is your feature. M is your slope and C is your intercept. So I know, I guess everybody knows the equation of line in, studied in mathematics. So we are using this line to model the relationship. So yes. So let's decode linear regression using three simple steps. And please always, do this using linear regression using three simple steps. So I follow a simple approach, that is what is my input. Input is your features, right? X1, x2, xn. So it's always not necessary that you will be having only y is equal to mx plus c. So I said, okay, only x, only one will be my feature. No, it can be y is equal to mx1 plus m1 x1 plus m2 x2 plus m3 x3 up to mn xn. So m1, m2, m3, these are your slopes, right? And you can say coefficients. And x1, x2, xn, these are your features. And Next is the process. So what's the process? You'll be finding a line. You have to find a line that best fits your data, and the output is your real valued response that we want to predict. So linear regression using three simple steps. Input is your features, process you have to find a line, output is the your real value response that we want to predict. Why it is I called it as real value, continuous value, I told you in the regression series. So mapping with the real world example, suppose you want to buy a house, let's say price of house depends on the area of house. So price of house is m into x1 is equal to this x1 is your feature, and price of house y is the response output that is that you want to predict. So we can model this relationship using a line. So let's go graphical way now. So let's understand with this help of in graph. So suppose you're given a data set and you plotted. So let's forget all this and just focus on the you have a graph and you just have these red points. Just see only these red points. Okay. So these red points with value x is 1, y is 6, x is 2, y maybe 5, x is 3, y is 7.5, x is 4, y is close to 10. So these are your data points that you have. Now you plotted these data points, x and y, you plotted these data points. And because there's a linear relationship between x and y, so what you're going to do? So you thought to draw a line. So you draw a line. And red data points are our data that we have already. Blue line is the best fit line that we want to find in linear regression. We want to find the best fit line. So how you're going to find the best fit line, that we are going to discuss now. And x is a feature, say area of house, and y is the output, say price of house. So let's focus on, so linear, what linear regression is doing is, so linear regression will draw, this algorithm will internally draw one line. Okay. And it will draw multiple lines. So this line here, line, any line with a different slope, you can rotate line. So different lines it can draw, and now I have to select the best fit line. How? So the green points, I mean the green lines you are seeing is what? It's the distance of the point from the actual data point to the line that it predicted. So this is also the distance. So let me call it as distance d1, d2, d3, and d4. What is the distance? Distance is the actual distance between the data point and the line. So this distance, what you want? This distance is what? This is your error, I think. I mean, this is the residual. So what you want? So let me provide you how to determine a line is best fit or not. So it will be trying different lines. It's not that blue line is always the best fit line. So it is one line. Okay. Now it can try, you can just rotate this line a more, or here. So multiple lines are possible. So there are infinite number of lines are possible here. So you'll be drawing different kind of lines here. And what you're going to calculate, you'll be calculating distances. Okay, and squaring it. So one of the question, please keep a note of it. So people can ask you, okay, you're calculating the distance here, but I mean, why you are squaring it? Why? Because this line is now, I mean, passing through origin. Okay, but it can pass through anywhere. So let me rotate this line more here. So this line, I mean, multiple lines are possible. So it's possible so that these two positive distances cancel out with these two negative distances. So it's a the sum of d1 plus d4 is equal to, so its distance is say plus 5 and its distance is minus 5. If you do so, 5 minus 5 is 0. Okay, so even if that distance is, I mean, even that line is not good, but still the residual is 0, so we'll be wrongly selecting. So what we are trying to do, we don't want this. So we'll be calculating the distance of the data point from the line, but we are also squaring it to lose out this possibility. So the green lines you see are the data points from the line, are the distances of the data point from the line, and are called the residuals. Okay. Next is, I mean, this distance is called the residuals. So if you someone asks, Like, what's the green line? What's this distance? So this distance is your residuals, right? Or you can say the vertical distances you see. Now it's coding time. So we'll be implementing, as I discussed, linear regression on a data set in Python. So I follow a four simple step. That is, get the data first. Next is will be creating the model, fit the model, and get predictions from the model. Create the model. Don't, I mean, wrongly interpret. Please don't interpret it wrongly. Like, for example, creating the model is just, I mean, I'm initializing it, okay, with the function. So I show you how. So let me go to my repo that I shared with you for the linear regression. So this is the linear regression, I mean, notebook. So I have highlighted so you can see. So I'm giving you few minutes, I mean 1 minute maybe. So you can go to this and we can get started. So hi all. I mean, I hope this link is visible to you. So please download that notebook and we'll be going. You can run that code on the go. So you can also implement it linear regression and submit it on your GitHub project to say, okay, I know these algorithms. So this might be very useful for your data science career if you are transitioning into that. So please, I mean, do that. So if you have any question, please mention in the comments. I'm seeing the YouTube channel comments also. So okay, so I hope, I mean, I gave a few minutes and now you're good to go. So the coding I have done is using this import libraries is the first step. So from sklearn.linear model import linear regression. Linear regression, why? Why? Because I'm doing the linear regression and sklearn I have imported. Now let me generate some random data. So in random data is I have generate only one feature here. Okay, 4, 12, 16, 20, 24, 36, 30. So you can visualize it as a row, a CSV with a single column with having values 4, 12, 16, 20, 24, 36, and 40. And what is your output? So its output is for 4 it's predicting 4, for 12 it's predicting 17. So there's the output y column 4, 17, 10, 18, 22, 38, and 33. So this is my label data set. Label data set because output I also know. For a particular X, I also know the output. For a particular 12, I know the output. 16 also I know the output, right? Now create the linear regression model and we are going to fit on the data. So what do I mean by creating the linear? It's just simply initializing. So don't misinterpret that. So linear regression I have initialized and my first linear model. Now I have to, I mean, fit your data set into a model that is input feature X and your output feature Y. So next is finding the slope and the intercept. So now you know, I mean, I have told you. So y is equal to mx plus c. So m is your slope and c is your intercept. So you can easily find using the dot coefficient COEF and dot intercept, right? So these you can simply invoke and find this. So what will be my line? My line will be y is equal to 0.883 into x plus my 1.097. So this will be my line. Next is get the predictions. So what you want is you have your model now because you have this model you have trained. My regression model is fitted on this data set. It has seen the training data set, and now you want to predict. So you said, okay, if my x value is 13, what will be my y? If my x value is 16, what will be my y? So you just have to say my first linear model dot predict, and you have to pass this 13 and 16. So for now it said, okay, for 13 my value will be 12.5, and for 16 my value will be 15.23. So that's what about linear regression is. So you have to, so what does linear regression summarize? If I have to tell, you have to um, two parameters. One is the coefficient, I mean that is your slope, and intercept, right? Or I can say coefficients, different coefficients. And the intercept here, it was only one because I have only one, and it was that much simple. So if I'm not able to run on the go, that's also fine. I have linked this notebook on this page. You can always run and see how linear regression is working. So that's about the linear regression. So congratulations, you successfully completed the linear regression algorithm along with the hands-on. So next is I'm going to tell you about is the classification algorithm, that is logistic regression. So please tell me in the comments if we are good to go to the next. So I am seeing how to download it. So these are the installation guidelines. Okay, how to download that file? Machine learning, if I'm go. So if you click on raw, if you click on raw, and you can copy paste in a text file and save it as ipynb file. So you can control A, control C, and save it as .ipynb, and you're good to go. I hope it's clear now. So you have to click on row where it is showing error, Ashwin. Like I already told you, like for these algorithms to run, you have to download this installation guidelines, and you have to install these packages: pandas, numpy, matplotlib, seaborn. Okay, so might be your package error, you might be showing. Extension is .ipynb. Or you can, I mean, completely download it as zip file. So you just click on code, and if you want all these files, so it will be downloaded as a zip file also. That also you can do. But if you want to do for a particular notebook, that process I already explained. 1 2 3 4 5 6. No, actually, the thing is, this line, Avni, sorry, to hin. So y is equal to 0.8883 into x plus 1.097 is just shown for, like, this is what your line is going to be. So you can comment this. Okay. So what I have told you in the slide is y is equal to mx plus c, and m, I from the algorithm, I from the model I got it as 0.883, and 1.097 is the intercept. So you can just put a hash in front of it and comment it, and then you can. So this is just for verification purpose. So you can also put your x values into 13 and do this calculation. This value will be equal to this 12.585. Yeah. Yes, Neha, if you are good to go, you are able to download it. You can, if you want to save it as a particular, you can paste it anywhere, a text file, and you can save it as IPYNB. Otherwise, just do one thing because you also need logistic and base and everything. So you just click on code and download it, copy here, and so it will download as a zip. So this download zip. Just click on this option download zip and it will give you the complete folder and extract in your computer, and then you'll be able to run this notebook. So linear regression we have completed, and while running, please, I mean, this was done just for verification purpose, how your line will look like. Yeah, one question is why we are reshaping the input feature X. So why I have done dot reshape this, right? So to flatten the, because this is a numpy array, and for flattening I did that. So minus 1 comma 1 if you do, so it will automatically know the dimension. You don't have to provide. It will automatically calculate. So that's about Suraj asked this. So I think we are good to go. Move forward. Let me, start the logistic regression with you. Yes, I just explained what does reshape minus 1 comma 1 means. So if you're running this notebook, so np.array, so just run this only, okay? np.array and see like the shape of this. You can visualize also. And after dot reshape minus 1 comma 1, you can reshaping means we are flattening this. And minus 1 comma 1, if you follow this, the reshape uh, contents, so it will automatically calculate the dimension. You don't have to specify. Yeah, that's what I'm telling. Minus 1 comma 1, if you see, if you specify minus 1, it refers to, an unknown dimension. and the reshape function will automatically calculate. You don't have to provide the dimension. So shape function, so in the shape function, what does it mean? The dimension means number of rows and the number of columns, but minus one will automatically calculate for you. You don't have to specify. For example, you can just try to do this np.array, okay, and just do it dot reshape of minus one. So NumPy will all, automatically figure it out. You don't have to worry about it. So after reshaping, you'll be your array will be flattened with multiple rows like 4, 12, 16, 20, 24, 36, and 40. So I already explained you while starting that session. So I hope it's clear now. So let me move forward to this logistic regression now. So Sudhanshu, I hope you got the answer. Yeah, because you have to flatten the array into multiple. Yes, for I mean random data, I have used this. So this data is completely random, or you can utilize random.rand function, or you have to specify the range. I mean from the starting to the ending point. Chirag, I hope it's clear. So we'll be starting the logistic regression now. So can you tell me uh, this logistic regression? It's what kind of algorithm? It's a classification, or I mean, what kind? Please comment. So first we did the linear regression, and now we are moving forward to logistic regression. So what we are going to solve it with logistic regression. So this is the agenda for today. So we'll be implementing what is logistic regression and understanding the equation of logistic regression and the 1 minute. So yes, I'm back. So first we are going to discuss what is logistic regression. Next is understanding the equation of linear logistic regression and the graphical understanding, and finally we are going to code it. So I hope you have already downloaded the whole zip file and now you are good to go for logistic regression also. So let's first understand what is logistic regression. So it's a very important algorithm for most of your problems. So please, I mean, next is what is logistic regression. So it's a classification algorithm and it predicts a binary outcome. So if you have seen my this the linear regression one, which is used to predict a continuous output like house price. We did example house price my is my continuous output. I mean it can take on any real value, and your I mean salary or your age. It's a Next is it is used when the data is linearly separable. Okay, so logistic regression, I mean the prerequisite when the data can be separated using a line. Linearly separable means you have some data points, but using a line you are easily going to separate. So that's what linearly separable means. And so what's the difference between logistic and linear regression then? So this is also one of the important, concept. So here we are not just fitting a single line to it, straight line to it, but we are using the sigmoid curve. So we have squeezed that line into a S-shaped curve. So from this slide, what are the important points is, first one is the linearly separable. Linearly separable means using a line, you are able to separate the data points. And second one is the sigmoid curve. Sigmoid curve is a S-shaped curve with values between 0 to 1. And we're going to see it. I'm going to show you the sigmoid curve and how we are going to use a sigmoid curve to fit the data. So next is equation of logistic regression. Now, I have told you in the linear regression session that logistic in the linear regression, what you said, b naught plus b1 x1 plus b2 x2 up to b and x and b1 b2 are your coefficient, x1 and x2 are your features in the data set, and b naught is your intercept. So y or fx is equal to this line, and this line is similar to what? Linear regression only. Okay, so what's the difference then? So what the thing is, b naught plus b1 x1, the right hand side can take any values. Okay, so it can take any values that is larger than 1 or maybe smaller than 0. So it can take on any value, but we want our output to be in the range 0 to 1. So we will be using the sigmoid function. So the right hand side value can take on any value that is greater than 1, or it can take on any value that is lesser than 0. Okay, negative also and positive also. So but we want the output to be in the range 0 to 1, so we use a sigmoid function. So it squeezes the output value to be in that range. Okay, so what sigmoid function is doing? Sigmoid function is squeezing the output value in that range. So what's the equation of sigmoid function? Y is sigmoid function is 1 divided by 1 plus e to the power of minus of x. But what I am doing is I'm providing it as x as f of x. So this f of x, you put it here. Sigmoid function is 1 divided by 1 plus e to the power of minus x. But for logistic regression, I'm putting this fx also here in place of x. So what you can say from this? So we can say logistic regression is the sigmoid of fx, right? Sigmoid is what? 1 by 1 plus e to the power of minus x, but in place of minus x, I have written f of x. So using this line, we are going to, using this S-shaped curve, or we can say the sigmoid function, you are going to do this. So what's the characteristic of sigmoid function? Sigmoid function will be providing values in the range 0 to 1 only, always. It will not be exceeding, uh, it will not be exceeding the value 0, the range 0 to 1. And that's why we are using the sigmoid function. So that's all about. I'm Let me, if you have any question, please comment. I'm seeing the questions also. So now let's go graphical way now, like to understand. So let's first discuss what is the sigmoid function curve look like. So sigmoid function curve is, as I already told, is a S-shaped curve. So its range is going to be 0 to 1. Okay, so let me tell you a real life example, that is the customer will churn or not. Okay, so if so this 0.5, how do you know the 0.5 is a good criteria or not? So what I'm saying is, if my value falls above 0.5, that will be classified as 1, and if my value falls in the range 0 to 0.5, that means it is classified as not churning. So this is the S-shaped curve. So decoding logistic regression, the three simple steps that we did in the linear regression also. So y or fx is equal to b naught plus b1 x1 plus b2 x2. Say we have two independent variables, x1 and x2, And we will be calculating the sigmoid, that is, I've told you, 1 divided by 1 plus e to the power of minus x, but here fx is this b naught plus, so this equation will go here. And next is we'll be deciding the threshold. So I say, okay, my threshold is zero point 0.5, so above zero point 0.5 will be classified as a 1, and any value below will be classified as 0, right? So mapping with the real world example. So suppose you want to predict whether the customer will churn or not. So as the target variable is binary, so 1 slash 0, that is churn or no churn, we can apply logistic regression here because the target variable is binary. Sigmoid will give us values in the range 0 to 1, and hence we can get a threshold, say 0 0.6. So above that value customer will churn, and below that the customer will not churn. So how do you know? I mean, you have to apply the logistic regression or classification technique here, because the target variable is a binary. Because the target variable is binary, 0 or 1, yes or no, true or false, churn or not churn. So that means you have is a classification kind of, because it's a category, and we can apply logistic regression here. And how do we classify? You just have to classify using this sigmoid S-shaped curve. But how? So this is a S-shaped curve. Let me go back to it. S-shaped curve. So if any data point falls above zero point 0.5, will be classified as 1, and below it will be classified as 0. So that's how we are classifying. So I hope it's clear. Tapping with the real world example also, if someone asks you. So now it's enough theory, so we will be coding this logistic regression in the notebook. So using the 4 simple steps, so get the data first, and next we'll be creating the model, the initializing the model, and then we'll be fitting the model and get predictions from the model. So I'll be going back to my this repository, and now instead of linear regression, I'll be going to logistic regression. So you can I hope you have all have downloaded that. So here we'll be doing, so I'll be giving you 1 minute so that you can also do that, and I'll be answering your questions in the chat now. So in the meantime you can do this. So please download this notebook, for better understanding, so you have a hands on also for every algorithm that you learn, theoretically also and practically also. So in the meantime, I'm answering your question. So will this video be available for recap later? So yes, Arjun, the video is recorded, and Chavi will get back to you. So yes, Gurpreet, it was a classification algorithm. You guessed it right. So now, I'm moving forward. I think, nobody has any questions. So yes, so we'll be first importing the library. So importing the library, instead of linear, you write it as logistic regression. The same data. What's the difference between this data and the previous data? Yes, the category. So first it was the real values, 5, 14, 18, 16. Any values were there in linear regression, but here it's a class. So it's class. So say for 4, the customer will not churn. For 12, the customer will not churn. 16, the customer will not churn. And for 20, the customer will churn. So for 0, the customer will not churn, and 1, the customer will churn. So I'm mapping it to this example, real world example. But in reality, the thing is, you'll be having multiple columns that are going to contribute to the target variable. Okay, so in real world data sets, but the thing is, I'm making it faster for you also, so that you can now do a hands on this session also. So that's why we have the input feature. There is no difference. I mean, input feature, you can take it in any value, but the difference is your output y. And previously, if I show you the output y here, so let me go back to linear regression. Output y was taking any value, 4, 17, 10, 18, 22, 38, 33, maybe 1000. But here it has only two values, 0, either 0 or 1. 0, 1, yes, no, true, false, right? Or these kind of category. So this was classification. So now you initialize it and you fit it. You create the logistic regression model. And after that, you have to predict. So say you have to predict for 13. So the customer is saying, okay, for 13, will I churn or not churn? So for the model is saying for 13, the customer will not churn. And for 16 also, the customer will not churn. So 0 means not churning and 1 means churning. So I hope now it's clear. And mapping to the real world example for the logistic regression also. So please download this notebook and run one by one, and you're good to go for logistic regression also. So next, I'm going to discuss with you in this module is the naive Bayes algorithm. So that is also the most important algorithm. So if someone asks you, can you use which algorithm can you suggest me for email filtering, right? So you can say naive Bayes. You can use naive Bayes for email filtering classification. So it performs very well for that use case. So the thing is, if I go to this machine learning in a new tab, for naive Bayes also, you have the similar notebook. So the thing is, you can easily run this notebook on your own because there is only one chain, that is Gaussian naive Bayes. Okay. So you can run this notebook, and I'll be telling you the theoretical concepts now. Yeah, 1 minute.
Hi everyone. As many of you were asking for the PPTs, and many of you were saying that okay, we want to have some side by side learning session with the PPT. So in that case, I wanted to say that we'll be sharing the PPTs with you in the lunch break. So that you can have a proper revision and there won't be any sort of problem for you all. And also, um, do let us know that if you have any other issue, any problem that you are facing, any doubts, you can just put it in the comment section. Don't worry about it because it's a total beginner friendly session. You can have any sort of doubts. And thank you so much, Gurpreet, for such a nice comment. I'm very much happy that like you are having a really great learning session today with Pallavi. And obviously, uh, like after this session you will be able to get start with the problem statement, which is a thing you cannot get started with such a in such a short time span. Okay, so with that case we can just start the session again. And also, you can just join our Discord community. It's bit.ly/easy discord. You can just join our Discord community. We are very much active there. And I have shared, yeah, lunch break would be there so that you can have some like 20-25 minutes of break in which you can have something. And obviously it that break will be so that you can also have some revision as well at the same time. So lunch break would be there. And apart from that, now let's get started. And also I've shared Pallavi's LinkedIn with you over the group. If you haven't joined the group, you can just check out the mails. We have shared the group link over the mails. We will be sharing the mails again with you all. So now let's resume the session.
Yeah, thank you, Chavi, for clarifying the doubts. So now I'm going to start the naive Bayes algorithm. So this is also one of the most important algorithm for today is the naive Bayes. So let's discuss the agenda first. So the introduction to conditional probability, because first I'm going to discuss about the math behind this algorithm also, along with the example. Next is understanding the naive Bayes classifiers, the assumptions of naive Bayes algorithm, and the applications on the real world datasets. So let's get started. And finally the coded, like the implementation in Python. So I have already uploaded the notebook under that repository under the name of Naviebase. So you can simply run that because it's similar to that with few, I mean, changes. So first one is the introduction to conditional probability. So as you might be aware of, introduction to conditional probability simply means we are calculating the probability of an event given that some other event has already been occurred. So this is notation is probability of A by B, means we are calculating the probability of event A given that B already happened. So B event has already happened. We are calculating the probability of A. And formula is probability of A given B is probability of A intersection B, or A and B are divided by probability of B. So you can see in this diagram also. So this is A event, this is a B event, and this is the intersection, that is a common area between A and B events is denoted by A intersection B and divided by the total probability of B. So that's going to be probability of A given the B has already occurred. So the Bayes theorem also, I mean, given this PA given B is you have to how to, I mean, learn this formula is I have developed a trick like PA by B. So just tweak this. So PB by A into the parameter here is also probability of A divided by probability of B. So this is called posteriori probability and the likelihood and the prior probability. So that's for all about the Bayes theorem that you want to know, and how we are going to use this Bayes theorem for the real world data sets, how you're going to use it. So I'm going to show it to you. So A and B are your events, and the probability of B should not be equal to zero, right? Because it's in the denominator. So we want that its probability not equal to zero. Now, let me explain you with the help of example, like why, in which kind of uh, numerical problems you have seen this. I mean, this is a real example. So suppose bag one contains two white and four black balls. So this is one bag one and this is bag two. So in bag one, you have two white and four black balls, and in bag two, you have three white and six black balls. So what I have done, you have bag one and bag two, and I said, okay, let me draw a ball at random. And when I draw a ball, it is found to be white. So you have to calculate the probability that a ball was drawn from bag two. So you have two bags, and I have drawn a bag. I mean, a ball, and it was white, and you have to calculate like it was drawn from bag 2. So you can simply apply the Bayes theorem here. So probability of bag 2, right? Because you have to uh, calculate the probability from bag 2 given that, but because you already know that the ball is white, so this is a given event that has already happened even, and you have to find the probability. Now what you have to do, just interchange this, w of sorry, white ball given bag 2 into probability of bag 2 divided by the total probability. So the ball can be also from bag 1 also, or it can be from bag 2 also. Okay, so this is the total probability. So like from the bag 2 and the bag 1, and when you calculate, so you can simply calculate it, I mean this. So this was the example. Now, let me move to the machine learning side of it. So, what are naive-Bayes classifiers? So, it's a family of classification algorithms that are based on Bayes theorem. So, Bayes theorem we now discussed. So, it's is using a probabilistic approach, and hence we can quickly predict. So, it is faster because it is using a probabilistic approach. Probabilistic approach means we are finding the probability, so it's very quick because we have to calculate the probabilities, and it is faster. So different type of variants of naive Bayes classifiers are there. First one is the Gaussian, next is the Bernoulli, and third one is the multinomial naive Bayes. And now I'm going to discuss with you. First one is the Gaussian naive Bayes. So in Gaussian naive Bayes, for when do you use? So for each feature in the dataset, so suppose you have a dataset with multiple columns, so each column will be a feature, and so for each feature, you have the values. You will be having some values. Okay, so let me go back to the initial data set. We have, I mean, marks data set of students. So person A is having age this and this marks, and person B is having this age and this marks, and person C. So age and your marks were my this features. Okay, so what I'm saying is the value in these columns are distributed according to a Gaussian distribution, or we can say normal distribution. So normal distribution, I mean, the value in these columns are distributed according to this distribution, that is normal. So normal distribution, what it means, normal distribution, anyone? Yes, so it is a bell shaped curve that is with mu is your mean, and this is your mean equal to mode is equal to median. So all the three values will be equal in a standard distribution, I mean normal distribution. So your values will be distributed according to this in Gaussian namespace. Next is the Bernoulli. Bernoulli, I mean, you already know. So here features are independent Boolean variables. Boolean variables, you know, 0, 1, right? So here your features are independent Boolean variables. Next is the multinomial namespace. So here samples represent your frequencies. Frequencies means that is how many times your feature is occurring. So let me give you an example of multinomial namespace. So for example, we are doing some text classification. Okay, so in the text classification, you know, I mean, this how many times a word is repeating, how many times a word is repeating. For example, here samples is repeating only one time. Okay, and some other feature is repeating say 2 times. So it is based on the number of times a word is occurring. So in these kind of applications you will be using multinomial naive bayes. So you can be asked in this in different your if someone asks you, okay, when can I use Gaussian naive bayes? I can use Gaussian naive bayes when my column, when my the values of column or the values of feature are distributed according to a normal distribution, that is Gaussian naive bayes, where the values are the Boolean variables, yeah, 0 or 1. Okay, then I can use with Bernoulli. And when my samples represent the frequencies, like how many time word count, right? So you can utilize different type of models like TF-IDF or bag of words or different um, latest models for doing that. So in that case, you'll be using the multinomial naive bayes. So I hope the difference between different naive bayes versions is clear to you. So next is the assumptions of naive bayes. So naive bayes considers features or predictors to be independent. So it is saying, okay, age is so I am considering the same data set of students with age and marks. So I'm saying, okay, age and marks, okay, are independent, so they don't have any relation. So independent means two events are independent means when the occurrence of one event does not have any effect on the other. So that means the events are independent. So naive base considers like every feature, all the features in my data set are independent of each other. They are not, I mean related to each other, and each feature will be contributing equally. Okay, so these are two assumptions that you have to take care while applying the naive bayes algorithm. Next is how to apply naive bayes algorithm on the real world datasets. On real world datasets, okay. So you understood, I mean, the Bayes theorem, and you understood, okay, when can I use naive bayes and why I have to use this algorithm. But now, okay, you say, okay, say I have a data set with say 50 columns, so how can I use naive bayes? So this is the answer for you. So you have to predict for a particular label, and x1 x2 up to xn are my features in your data set. Suppose you have 50 features, so like age, your marks, your marks in maths, marks in science, everything. Okay, so these are your features. So what you'll do, you will be applying this with your this x1 give x1 given yk, y is equal to k means k is what, y is equal to k means it is belonging to class A, so k will be say class A, y is equal to A. Then we'll be calculating y is equal to b also if it's belong to class B, or y is equal to c also if it's belonging to class C. And whatever probability for a particular row, I mean it's greater, will be going moving forward in case of when we're testing. So if you see, it's a joint probability distribution in the joint probability distribution, but because we know the features are independent, so independent means you can simply multiply these. So x1 given y is equal to belonging to class A, x2 given y is equal to belonging to class A, and up to this. So this is how you can apply naive bayes algorithm on the real world datasets. So keep note of this equation, and this might be very useful for you. Next is the, okay, I understood everything. Now, what are the applications where I can use? So, spam filtering, I already told you. You have to, in email, okay, you have to filter like, is my mail spam or not spam? Next is the sentiment analysis, right? Next is the text classification. Okay, so in text classification, what version of naive bayes you are going to use? Can you comment? So we have three versions. So what version you're going to use? So yes, we are going to use the multinomial naive bayes. And the recommendation systems also you can utilize the naive bayes algorithm. Next is this is the question that I have been also asked in my interviews during my journey of data science. So why naive bayes is also is called so naive. So as you already know, so it assumes feature to be independent. Why? Because it is saying every column, every feature is independent of each other and it does not have any effect on the other. But it is where this assumption is very unrealistic for real world data sets. Why? Because um, the features might be having effect on the other. I mean, it's obvious, right? But naive Bayes is saying no, every feature is independent of each other. So this assumption is unrealistic for real world data sets. So that's why naive Bayes is called so naive. So this is the important slide for naive Bayes algorithm, because this question is important. Next is we are going to code it. We understood the different, I mean, the variants of naive Bayes along with the applications and how do we apply naive Bayes on real world datasets along with the equation and the real world example that I told you in the starting for the conditional probability. And now we are good to go to code it. So we get the data first. We will be initializing, create the model, fit the model, and getting the predictions from the model. So yeah, um, I'm going to the same repository. So open link in new tab. This is my new base.
Yeah, I guess there was some sort of network issue from Pallavi's side due to which she left. So till then, uh, okay, many of you were saying that you haven't received the WhatsApp group link. So let me just share the WhatsApp group link with you with the chat box. You can just join this WhatsApp group, and so that we can have some smooth conversation regarding this. If you are having any sort of doubt, you can just DM me anytime, and I would be very happy to resolve them all. So you can just join this WhatsApp group. I've shared the link with you over the chat box. Join it, and we can have some smooth conversation. If you are coming up with any doubt, if you are not able to how to submit it, any link, anything, you can just put it. Like you can just DM me anytime. I'm in the admin role. Okay, and also that I would be putting all the important informations, like for example regarding the submission part, or for example you want to extend the time or anything like that, so you can just let me know. And all the important information like links would be there in this particular WhatsApp chat only, so you can just have a look into it, and then we can have some smooth conversation. So yes, Pallavi is back. Yeah.
So yeah, this is the Naive notebook you already have downloaded. So I'm using the Gaussian Naive version here. So I have told you different variants. So I'm using the Gaussian Naive. Next is the input feature X.
Uh,
Similarly,
Pallavi, I guess your screen is not shared yet.
okay, okay, yeah. Share screen. Yeah, sorry.
Okay.
So I'm going on this notebook, naivebase.ipynb notebook. So you can also run this notebook for better understanding. So I mean it's simple. So I'm using the Gaussian Naive version. So we discussed three versions: Gaussian Naive, Bernoulli, and the multinomial. and these are my classes belonging to class 1 or class 2, and you have just create the model and the fit on the data. And for this, I have to predict. So you can say, it's belonging to class 2. So it's very simple. You can run these notebooks. So now, we are done with the module 3 also, and we can move to performance metrics in machine learning with module 4 and 5. So this is going to be very important, performance metrics in machine learning, for today's session. Yeah. So say for a classification algorithm, I have trained my naive Bayes also and my logistic regression also. So now I'm in see which metrics are performing. I mean,
Pallavi,
for
actually,
which
I
algorithm. So that
hello,
means I'll go with that algorithm.
Pallavi.
So that's why I'm going to move to performance metrics in machine learning, because I will be evaluating these metrics, and now we can be sure of like which algorithm does naive based or logistic regression will be good for us. So I'm going to, yeah. So this is the performance metrics in machine learning. So this is the agenda for today. So we'll be discussing the regression and the classification metrics. So let's discuss the regression metrics first. So first one is the mean squared error. So in mean
Okay, I guess there is some sort of
mean
network issue from your
squared
side.
error. So
Let me
error
just
means what?
check it once.
Actual minus predicted. Okay.
Just give me 1 minute. Yeah. So, guys, actually, there was some network issue from her side. No issues, but yeah. Till then, what you can do, you can just have a, quick recap of what you all have like got to know, got to understand, and just you can just join this particular WhatsApp group link. That you can just join this WhatsApp group for the further communication. I'll be sharing the important stuff with you over this WhatsApp group only. You can just be updated over here, and also till then you can just work upon work upon your like skills, have some lunch, and since it's around 2:30, so we'll be having like 20 minutes of lunch break. Okay, till then you can just explore more about machine learning, have a a revision, a recap session. You can obviously if any of your topic got left, you can just have a look into it right away so that you can have questions to ask and be ready with your questions, and because we will be deep diving into some other topics now. So till then, we will be having around 20 minutes of lunch break. So after that, we will be resuming it. So see you all after 20 minutes. Hi everyone. Let me just give you heads up on the group as well that we are going to start. And till then, if you have any sort of question related to anything, you can just ask Pallavi right away. We'll be having a like small 5 minutes of Q&A, or like if you want to have a recap or anything like that. That okay, what topics that we have covered till now, you can just ask that, and then we'll be starting at 3 5 or something. Okay, if you have any doubts, you can just start putting it on the in the comment section, and then we can just resume our session. Okay, perfect. The stage is all yours. Let me just put up one message. If you are facing anything, okay, I guess more and more people have started joining now because it's the end of the lunch break. So let's everyone join in. Let's wait for more people to join in so that we can just resume it. How many modules are left to be covered? I guess like 2 to 3 modules are left, not much. Anything else you want to ask, or anything you want to know about Azure Developer Community? Anything? You can just let me know. I would be very happy to answer them all. Anything that you want to know about Azure Developer Community, how it works, or why are we here about this marathon, how we come up with this idea, anything. What do we have to submit at last? Can you elaborate? Okay, so basically right now what we are talking about machine learning. Okay, we talked about what is the introduction, what are the algorithms, and a lot of stuff. So in that case, we would be providing you a data set and a problem statement. And what you have to do, you have to work on the like problem statement according to the data set. And like you have to come up with a solution. You would be like provided with a proper detailed description that how you are going to proceed with it, and also how you are going to do everything, like how you have to work on the solution part. So don't worry about it, everything will be explained to you in a very nice manner in the form of documentation. So that's how we will be providing it to you. And then after that, you have to go to the website on which you have registered. You can just see the website is coming up to you here. It's reskill.com/hack/ml marathon. You have to go to this website, and then after that you have to if you haven't registered, register to the website. And after that you can see a dashboard button that is coming. Then you have to click onto the dashboard, and then you have to click onto the submit idea, and you can just easily submit your stuff. And all the questions there would be updated super soon after we because we don't want to tell you the problem statement for now, so we are keeping it a surprise. So after sharing the mail, we would be updating that as well, and then you can just easily do it. Collab link in what sense? Can you please elaborate more of it? Okay, so we have in the Jupyter notebook only. Yeah, PPT would be shared super soon. We are just putting up in the drive, and I'll be just sharing the drive link with you. So don't worry about it. I'll be just sharing it. And again, so what you have to do, you have to let me just share my screen and show you just how you are going to proceed with it. Give me a minute. Perfect. So it's done. Let me just share my screen quickly. I'm sharing my screen. You can see. Okay, so after the registration stuff, okay, like after you would be registering, so you would be going to this website. After that, after your registration procedure, when you will reach out to this website, how it's gonna look like, it will show you dashboard button. Okay, so what you have to do, you just have to click on the dashboard. The moment you will click onto the dashboard, you will be headed over to this particular stuff. So what you have to do, you just have to click on the ML solution. Okay, click on submit idea, then just fill this up, and obviously we would be just updating this super soon. After you would be receiving the data set, the PPTs and everything, after that this will be updated. Don't fill this right away because we haven't shared the problem statement with you yet. So what you have to do, you have to just what you have to do, you just have to complete these details. You can just share the Jupyter notebook link over here, and you can just share the CSV file URL with predictions over here. So these things you can do. You can share the GitHub ID and the other stuff. I'll be just adding up most things over here super soon. Don't submit anything right away because obviously then it won't be counted. So this is the one thing, and that's how you can just easily do it. So that's pretty much just that how you are going to proceed when we will resume. So How to share Jupyter notebook link. Okay, so that will be like taught by Pallavi only. She'll just give you a proper heads up that how we are how you can just share the Jupyter notebook link, how you can share the CSV file link with predictions. So everything will be taught to you after like explaining that what's the problem statement and everything, because then only you'll be able to understand how it works, how the data set actually looks like. So for that you actually need some more and more experience. So just give me 2 minutes and then I'll be just resuming the session. I was actually receiving some there's a submit idea in Reskill website. There you can submit it. Yeah, thanks, Shrikar, for explaining that. Okay, so with that note, I actually received a few queries from some of you in the DM that okay, like today we are having a lot of module session today, and also there was some sort of network issue from Pallavi's side. So I thought so let's have the other modules session tomorrow, because today you can just have a proper revision, you can work on the other stuff as well. And with that note, we are also extending the time for our submission. Okay, so we will be covering the leftover modules tomorrow at 12 p.m. only, and those will, like, the tomorrow session would be from 12 p.m. to 2 p.m. Okay, and there you will be properly taught that how you can actually share the Jupyter notebook link, how you can share the CSV file link, how you can actually put everything on your GitHub, and everything will be explained to you in a very nice manner. So don't worry about it. And till then, just have some more research. Be like, try to have some guesses at what sort of problem statement that we can provide to you, and you can have some research on that how you can work on data set, so that you can have some previous knowledge, and then you can easily start working on it accordingly. And then with that note, uh, yes, again saying telling you all that tomorrow we'll be resuming this session. The leftover modules will be taught to you in the tomorrow session that will be conducted at 12 p.m. to 2 p.m. Okay, at 12 p.m. we will be coming here only talking about the other modules, and then we will be taking the session forward, and we are also extending the deadline from 9th October to 10th of October. So you will be having some more time to like have it. So in this today's session, we covered what is the introduction to machine learning, what are the prerequisites that you need to understand about machine learning, what are the basic algorithms like linear regression, logistic regression, and naive Bayes. So, in the tomorrow's session, we would be covering the performance metrics, clustering algorithms, hands on project, and tree based algorithms, by which you would be able to work on the. Yeah, thanks a lot, Mansi, for understanding. And also, again, I was also receiving some queries that it's quite difficult for you as well to have so many things in just a day, because I guess many of you started your his or her GitHub journey today only, started your Jupyter notebook journey today only. So you can have some more time to like have some good experience on those stuff. Okay, and also you can also have some more look on the other stuff that you can do. And I have already told you that which topics that we will be covering tomorrow, so you can just have some research on it. You can be more prepared with the questions and doubts beforehand. So with that note, thanks a lot everyone for joining in. We will be resuming the session tomorrow at 12 p.m. here only at our YouTube channel. So till then, have a great day. Bye bye. Take care, and let's see who's gonna win, and who's like what what will be the top 10 projects that we would be receiving at the end of our ML marathon. So have a great day. Bye bye. See ya.